Hi guys, today I'm going to teach you how to solve a system of equations by elimination. The other two ways we've solved systems of equations so far are graphing and substitution. Okay, elimination is the third way I'd like to show you how to solve a system of equations. So if these are the two equations that you're given, notice that this is number 11 on your worksheet. There's just not a whole lot of room for me to work, so I'm working it on this page. You're more than welcome to work it on your own notebook paper or on the worksheet itself. Okay. If this is the system we're dealing with, and you know it's a system because it has a little bracket, right? The way that we're going to solve this system by elimination is we're going to combine the two systems. Sometimes this method, besides elimination, is also called linear combinations. I like to call it elimination because I feel like an assassin, because I've got to get rid of one of the variables. That's my goal, is to get rid of one of the variables. Okay? Notice here in this problem, I have a positive b and I have a negative b. If I combine those two systems, like I'm adding them together, I get a plus a, which is 2a. I get b minus b, which is 0. So I have eliminated that variable. Equals 26. And then if I divide both sides by 2, I get a equals 13. Remember back yesterday and also to Monday, what is the answer to a system of equations? How do we write our answer to a system of equations? When we graph them, it's where they cross, if they do. So hopefully you realize or remember that the solution to our system of equations is an ordered pair. So now that I know A, I've got to go find B. Okay? Probably, excuse me, substitute A into the top equation. 13 plus B equals 19. Then all we have left to do is solve for B. So subtract 13 from both sides. B equals 6. So the problem here is I'm telling you it has to be an ordered pair, except we have A and B. We don't have X and Y. Okay? So we have a couple different options, and depending on who you listen to, like which mathematicians you listen to, because people fight about stuff like this, not me. I don't care that much. Okay? We have two choices here. We can write A equals 13 and B equals 6, and we can circle that as our answer. Or we can decide, since X and Y are in an ordered pair alphabetically, whatever two letters we choose, we can put in an ordered pair alphabetically. Okay? It doesn't matter. This is probably easier for A and B. This is probably easier for X and Y because that's what we're used to. Okay? So what we're looking for in a system of equations is variables that will eliminate easily. And the way that they'll eliminate easily is if we have a positive value and a negative value. Okay? If we have a positive value and a negative value, hopefully you see when we add them together, they will go away. They will go to 0. Okay? So problems like this, yeah, that's easy, right? Well, there's some other problems that might show up, like problem 15. Okay? In problem 15, I have 3x plus 2y equals 4. And then I have x plus 5y equals 62. Now, again, in order for them to eliminate, they need to be opposite signs but have the same coefficient in front of the variable. In this problem, do you see something that has opposite signs but the same coefficient? That's because there's not one, right? We have a positive 3 and a positive 1, and then we have a positive 2 and a positive 5. Neither one of those will eliminate right away. So we have to manipulate the problem, being very careful not to change the value of the problem, but we have to manipulate this problem to make it easier on ourselves. Okay? What if this variable was, this coefficient right here, what if that was a negative 3? Would that make things easier? Well, if this is a positive 3 and that's a negative 3, hopefully you see that that would make things easier for ourselves. So I'm going to rewrite the top equation. And then, to the second equation, I'm going to take the whole entire second equation and multiply it by negative 3. Now again, where did I get the negative 3? Hopefully you see that I needed this to be a negative 3 so that it would be opposite sign but the same term, okay, the same number. Okay? If I multiply that entire second equation by negative 3, I get negative 3x minus 15y equals a negative 186. Okay? 62 times 3. Yep, 186. Negative. Okay? Now I can combine these to eliminate a variable. And look what happens. 3x minus 3x, that goes to 0. 2y minus 15y gives me a negative 13y. And negative 186 and 4 is a negative 182. Okay? When I divide both sides by a negative 13, y equals 14. Okay? Now again, I'm not finished because I have to solve for x. Okay? Now I can choose either one of these first two original equations to plug my y or substitute my y back into to solve for x. So it's really your decision which one you choose. But remember, sometimes my job is to figure out what would make it easier for you. If I put 14 here, which would be fine, I'd multiply it by 2, subtract it to both sides, and then I have to divide everything by 3. However, if I substitute my 14 into the bottom equation y, yeah, I have to multiply it by 5 and subtract that from both sides, but then my x is already solved for because my x is by itself. So I could say x plus 5 times 14 equals 62. Now 5 times 14 is 70, so x plus 70 equals 62. And when I subtract 70 from both sides, I know what my x value is. Okay? This is an x value and a y value, so I can come over here to the side and say my answer is negative 814, because that's my x and that's my y. Okay? And that is my solution. Alright? So, if they're already same sign but opposite, different signs but the same number, we got that. Now we've got it also if we only have one variable with a 1 as its coefficient, because we can just multiply there. But the problem comes when we have something like this. 4x plus 5y equals 70. And 3x minus 2y equals 18. And this is problem number 17. Okay, problem number 17. Now, first of all, I want you to notice that 4 and 3, you could probably very easily find a number that they both can multiply to, or both divide into, pretty easily, right? 4 and 3, that would be 12, right? So we could make both of our x values 12. But look at the y's also. 5 and 2, that's not very difficult either. We could make both my y values equal to 10. Which one would you do? Would you make your x's 12 or would you make your y's 10? Hopefully, first of all, it doesn't matter. Okay? First of all, you need to know that it doesn't matter. As long as you do all your arithmetic correctly, it's not going to matter. But what I want you to realize is that while your x's are the same sign, your y's are already opposite signs, which is what we need. Okay? Since the y's are already opposite signs, let's go ahead and do the y's. Let's eliminate the y's. So everything in the numerator has to be multiplied by a 2 to eliminate, or to make this become a positive 10y. And everything in the denominator, I don't know why I'm saying numerator and denominator, sorry. Everything in the first equation needs to be multiplied by 2. Everything in the second equation needs to be multiplied by 5, because that would make the y term negative 10. Then I would have a positive 10 and a negative 10, and those will eliminate. So when I multiply everything in the first equation by 2, I get 8x plus 10y equals 140. When I multiply everything in the second equation by 5, I get 15x minus 10y equals, I don't know that one, 18 times 5, 90. Okay? Now, I have same number, opposite signs. Once I have same number, opposite signs, I combine my two equations. Okay? 8 plus 15 is 23. Sorry, 8x plus 15x is 23x. 10y minus 10y is 0. And 140 plus 90 is 230. Well, once I divide both sides by 23, I know that x equals 10. Okay? Now I'm not done, remember. Now I have to take this x value and put it back into one of these first original equations to find my y value. Okay? Again, it does not matter which way you do it. Just choose one of them and go with it. Okay? I'm going to choose the first one, just because it's first, probably. 4 times 10 plus 5y equals 70. 4 times 10 is 40, plus 5y equals 70. Subtracting 40 from both sides gives me 5y equals 30. And dividing both sides by 5 gives me, y equals 6. I have an x and a y value as my answer, so I need to come over here to the side and say x is 10, y is 6. Okay? Now, haven't really focused on this. I know I've done 3 examples for you already, but one of the important steps, and you'll see why probably, hopefully, in a couple days, so it's not immediately important, but it will be soon, is we have to make sure that this is actually the right answer. Okay? And the way that we can do that right now is by substituting both of these values into each one of these equations. So if I said 4 times 10, that would be 40. 5 times 6 is 30. 40 plus 30 is 70. Well, that's right. Okay? But I also have to plug it into the second equation, just in case. Okay? 3 times 10 is 30. Minus 2 times 6 is 12. So 30 minus 12 is 18. See, the thing that does for you is that makes you absolutely sure that your answer is right. Okay? There's no questioning. There's no worrying, anything like that. Okay? So, I've done 11 and 15 and 17 for you. You are responsible for the rest. 12, 13, 14, 16, 18, 19, 20. Okay? Please take the time and work on that now. As long as you can stay quiet, you can work in groups. If it gets too loud, you'll have to work alone. So if I were you, I would keep the volume to a minimum. Working with your groups, I understand there's going to be talking, but keep your talking on topic and keep your talking at a normal volume. Okay? I hope you have a great day. Please get to work and get this finished before you leave. Have a great day, and I'll see you later. Peace.